So we're continuing here. We found that our 0, where we're crossing the x-axis, is about at x is approximately 1.8. So the positive values, where does our function exist above the x-axis? Well, since we're crossing the x-axis at 1.8, we'll notice after x value of 1.8, that's where we're above the x-axis. So that means our positive values exist from 1.8 all the way to positive infinity. Our negative values, where a function exists below the x-axis, is going to be everything else. So that's everything down and to the left from negative infinity to 1.8. Increasing, again, if we look at the general shape, it does look like it's generally increasing. So it's going to be increasing from negative infinity to infinity. It's decreasing nowhere. This function is actually going to be neither odd nor even. We can plug in some values if we want to, but because we're doing some kind of stretching and moving, it's going to screw things up. It's going to make it neither. All right, we're going to look at one more of these. So let's plug it into our calculator, see what happens. So I'm just going to change this top equation. Negative 1/2, I'm going to make it negative 0.5 times quantity x plus 2 to the third power. And outside my power, now we add 2. Let's see what this graph looks like. So now we've flipped again. We've moved over to the left. If we hit second graph there, we can get some values on our table. Looks like some really yucky things there. So let's pick these values. So negative 3, 2.5, negative 2, 2, negative 1, 1.5. So negative 3, 1, 2, 3, and 5 halves, 2.5, 1, 2.5. Value there. Negative 2, 2, put us here. And negative 1, 1.5 puts us about here. This is our general shape. Not very good, but it is what it is. Domain, we're thinking about all of the possible x values. We're going up and left forever. We're going down and right forever. Domain is all real numbers. Range is all real numbers. And behavior, as x goes to positive infinity, as we look to the right on our graph, what are the y values doing? They're going down. F of x goes to negative infinity. As x goes to negative infinity, as we look on the left side of our graph, where are y values doing? They're going up. So they're going to positive infinity. Zeros, we need to find that intersection again. So we hit second and then trace, opens up the calculator, intersect. We pick our two lines, we make a guess, tells us our x-intercept is about at x of negative 0.4. So our positive values, where a function exists above the x-axis, that's everything in all those big negative x values. So that means from negative infinity to negative 0.14. Negative values where a function exists below the x-axis is going to be everything else, negative 0.4 to positive infinity. This has a general shape like this. That means it's decreasing forever, increasing none, negative infinity to infinity. This is another one that's going to be neither. So thinking back to what effect these values have on our graph, how it reacts. If we multiply by this negative number, so if we multiply our quantity by a negative number, it's going to reflect across the x-axis. That's when our graph flipped. It reflected across the x-axis when we multiply by the negative. Stretch or compression, when we multiply by something bigger than 1, that's when it stretches. When our value is being multiplied by something between 0 and 1, that's when it's going to compress. Now these are vertical stretches and compressions. We are not working with the horizontal ones. So vertical stretch or compression. Horizontal shift. Well, this is where things get a little funky. If h is positive, it moves to the right. If h is negative, it moves to the left. What does this look like? Remember, this is where it's going to be x minus h and then x plus h, because it's backwards in our mind. If we're doing x minus h, we're moving to the right. Vertical shift, this one's a-okay, plus k, adding a number on the outside of the function moves us up. Subtracting Number on the outside moves us down. So just analyzing our equations here. We just have f of x equals negative x cubed. This one just has that x-axis reflection when we multiply by that negative value. This one, we don't have a reflection because we're not multiplying by a negative. We do have a dilation. We're multiplying by 2. So that means we're stretching by a factor of 2. That's a vertical stretch. Translation, inside the function affects the x's and it's backwards in our head. We're going to move to the right 1. Outside the function is telling us the vertical movement. We'll move down 1. On this one, reflection, we're multiplying by the negative. So that means we have an x-axis reflection. Dilation, we're multiplying by 1/2. That means we're going to be doing a compression by 1/2. Translation, inside the function is affecting the x values. Backwards in our mind, we're moving left 2. Outside the function is our vertical movement. We're moving up 2. So we're going to use these values. Now we're going to start looking at the graphs and see how to come up with the equation then based on the graph.